Hello everyone, this is R. Vahita, Assistant Professor of MCA Department from Rohini College of Engineering and Technology. I am here to discuss a topic about identification of classes and relationships and identifying the state and behavior from Unit 2. First, let us see about how to identify a class and their relationship. A class represents a collection of objects having the same characteristic properties that exhibit the common behavior. It gives the blueprint or the description of the objects that can be created from it. Creation of an object can be a member of a class, which is called as instantiation. Thus, an object is an instance of the class. The constituents of a class are a set of attributes for the objects that are to be instantiated from the class. Generally, different objects of a class have some difference in the values of the attributes. Attributes are often referred to as class data, a set of operations that portray the behavior of the objects of the class. Operations are also referred to as functions or methods. For an example, of a single class, that is a circle that represents the geometrical figure in a two-dimensional space. The attributes of the class can be identified as x coordinate of the center and y determines the y coordinate of the center, a to determine the radius of the circle, and the operations can be defined as find area method to calculate the area, find circumference method is to calculate the circumference, and scale method is used to increase or decrease the radius. The relationship in the class diagram. Classes are interrelated with each other in specific ways. In particular, the relationships of the class diagram can be of different types of logical connections. It is possible as association, directed association, reflexive association, multiplicity, aggregation, composition, inheritance or generalization, and realization. Association. Association is a broad term that encompasses just about any logical connection or relationship among the classes. For example, passenger and airline may be linked as below. So directed association is have a arrow with it. Okay, so directed refers to the directional relationship represented by a line with an arrowhead. Arrowhead depicts a contained directional flow as shown in the figure. The reflexive association occurs when a class has multiple functions or responsibilities. For example, a staff member working in an airport may be a pilot, aviation engineer, a ticket dispatcher, a guard, or a maintenance crew member. If the maintenance crew member is managed by the aviation engineer, that could be a managed by relationship in two instances of the same class. Multiplicity, it is the active logical association when the cardinality of the class in relation to another is being depicted. For example, one fleet may include multiple airplanes, while one commercial airplane may contain the zero to many passengers. The notation 0 asterisk in the diagram means 0 to many. Aggregation, it refers to the formation of a particular class as a result of one class being aggregated or built as a collection. For example, in the class library is made up of one or more books among other materials. In aggregation, the contained classes are not strongly dependent on the life cycle of the container. In the same example, books will remain so even when the library is dissolved. The show aggregation in a diagram, draw a line from the parent class to the child class with a diamond shape near the parent class. The diamond shape denotes aggregation. Composition relationship is very similar to the aggregation relationship, with the only difference being the key purpose of emphasizing the dependence of the contained class to the life cycle of the container class. Container class will be obliterated when the container class is destroyed. For example, a shoulder bag side pocket will also cease to exist once the shoulder bag is destroyed. To show a composition relationship, a directional line connecting the two classes with a filled diamond shape adjacent to the container class and the directional arrow to the contained class. Inheritance or generalization. It refers to the type of relationship wherein one associated class is a child of another by virtue of assuming the same functionalities of the parent class. In other words, the child class is a specific type of the parent class. To show the inheritance in a UML diagram, a solid line from the child class to the parent class is drawn by using a unfilled arrowhead. Realization denotes the implementation of a functionality defined in one class by another class. To show the relationship in UML, a broken line with an unfilled solid arrowhead is drawn from the class that defines the functionality of the class that implements the function. In the example, the printing preferences that are set using the printer setup interface are being implemented by the printer. So now we are going to identify the state and the behavior. All the objects have three essential features: state, behavior, identity. An object state is defined by the attributes of the object and by the values they have. Attribute is a feature of the object which distinguishes it from the kinds of object. For example, one of the attributes of any car object is capable of movement, it has a speed. Behavior and identity. We can model the states of the system by defining the states of the object that represent it. Objects always exist in some kind of relation to another objects. So an operation occurs when the message is passed between the two objects that we have already seen. For structural and security reasons, some operations and attributes in the class of objects are visible to other classes. The three most common types of operations are modifiers, selectors, and iterators. Modifiers operation alters the state of the object. Selector that access the state of the object without changing it. Iterators allows all the parts of the object to be accessed in definite order. So these constructors and destructors we have seen in the last listing. Thank you.